Logging and monitoring is an easy place to get distracted and get poor results. And a good place to start is to think about it from the concept of Maslow's hierarchy of needs. There's a theory about, the basic foundational components of survival have to first be met, and then you can later grow into, your true self and be self-actualized. Similarly, with software, we have a hierarchy of needs, and a lot of times with Python or Rust or Go or whatever JavaScript, you may first start off with just print or console.log. And it's a very primitive form of debugging. I mean, it's better than not having debugging, but there's some downsides to that. Let me explain one of the biggest downsides to print is, let's say you're a new Python programmer and you first start out, putting a bunch of print statements in 1,000-line Python script. And it turns out that maybe it takes an entire day to debug something. Finally, you get the fix. You're like, awesome, this is great. And you delete all those print statements. You just deleted a day's worth of work because, you believe it or not, probably 2 weeks later, you're going to have a similar bug. And what are you going to do? Re-implement all of those prints again and spend another day tracking down the bug. Eventually, you start to realize, there's something wrong here. And this is where logging comes into play, is that's exactly the point of logging. So I would say level one of the hierarchy of needs, or kind of survival with logging and instrumentation, is the print, but we can do much better than that. And the next level would be using a logging library, because it solves that problem of wasting the prints. Now, how do you actually, go from having all these prints that are annoying to only turning them on when you need them? Well, this is what the log levels do. So in the case of, Rust or Python or Java or JavaScript, there's logging libraries that have levels. So log.debug would be for that scenario where you have a bug, you want to get verbose logging. And so you set the log level to log.debug. And then you can go through and look at all the different things inside of the logging. Now, next, though, there could be a problem where you want to then put it into production. Well, how do I switch it? Oh, okay, well, now we have log.info. And log.info would be much less verbose logging. The info would be maybe the transaction started, the transaction was successful, right? So you just have some basic logging so you understand what's happening. Then we also could have exception logging. So in the case of Python or any language with exceptions, you could say try, put some logic, and then do try.except, log that exception. And then, maybe in a metrics dashboard you build, how many exceptions are happening in a production system. So there's some great things that you get from having the ability to do log.debug, log.exception, and also maybe log.error, which there's some similarity there. You could also specifically have certain log messages for errors, and then you could also do a dashboard for that. But again, we can go much better than just that logging level. And we can also even divide this section into two subsections. For example, unstructured logs. One of the problems with unstructured logs is that you can't get exactly all of the information. You have to use a search tool or, do some kind of pattern matching to get the information. But if you have structured logging, like in the case of JSON, now you can start to do a query for a key value pair. And this is a great way to go to the next level of logging, is to do structured based logging. And you could also build counts and metrics and dashboards. And so there's even a sub-level amongst logging, and this would be the structured logging data. But we can go even further. Let's go to the next level here, which is level 3, which is tracing. Now, what is tracing? Tracing is the ability to track execution paths through code by using unique trace IDs. So you would capture maybe the entry point, the exit point with timing data, and you could figure out how long a particular function takes. You could do performance profiling, you could do hotspot identification, and also it's lower overhead than maybe a traditional profiler. And in terms of open source, we have things like OpenTelemetry, which is a vendor neutral way to do this. And so the tracing allows you to really get into the weeds of the life cycle of your software. And so this adds yet another level of sophistication that you can use when you're debugging production software. Now, in terms of going further, though, we can still go further. In the case of microservices and serverless, we could have maybe 5 or 500 or 1,000 transactions that are happening all across different serverless endpoints. How do you know what's happening? It's impossible to know what is exactly happening without some form of distributed tracing. And what distributed tracing does is it propagates the trace context across the processes and the service boundaries, and it correlates the requests spanning multiple microservices. So you can essentially visualize end-to-end request flow through a system architecture, even though it's hitting all kinds of different endpoints, and you can even identify cross-service latency and bottlenecks, and you can provide service dependency mapping and also implement sampling strategies to reduce overhead. And some open source implementations would be, again, like an open telemetry collector or Grafana, right? Some of these tools will be very helpful in doing distributed tracing. Now, let's get to the final level here, which is observability. So even in those cases where you have logging and tracing and distributed tracing, etc., that doesn't get everything because there are other components of a system. It could be CPU or memory or disk IO or maybe systemic issues across networking. And so what observability is it's the unified approach to combining logs and metrics and traces, and you can have a focus on unknown detection. So looking at anomalies and looking at weird things or high cardinality data collection, real-time analytics, event correlation. So essentially, by looking at everything at once, this is the classic data science approach of exploratory data analysis. And you can do observability with maybe Grafana and Prometheus, or Open Telemetry Collector and Prometheus, or Elasticsearch and Elk Stack, right? There's all these different ways to think about this, but the concept of observability is that just like you have a dashboard in a car or a plane or some kind of vehicle, you're really looking at things in a holistic manner. And you also have the ability to dive into each of these subcomponents and take a look at it. So that's really the takeaway here, is that it's easy to get caught up in just print statements, but it's important to know that that's the basic level of being able to survive. You need to go to a deeper level, until finally, in a real production system, we have observability.